Hello, this is Shannon Gracie. We are now on section 1.4 from the Blitzer book with introductory and intermediate algebra, and we're covering the basic rules of algebra. So our goals for this section, are to understand and use the vocabulary of algebraic expressions, use commutative properties, associative properties, distributive properties, combine like terms, and to simplify algebraic expressions. So let's get you all warmed up here. Go ahead and pause the movie and start warming up. All right, let's see how you did. Recall that when you are dividing fractions, you're multiplying the first fraction by the reciprocal of the second fraction. So here we can rewrite our 57/4 will multiply by 2/3, which is the reciprocal of 3/2. Remember, nothing in math is free, so the way we paid for changing that sign is to multiply by that reciprocal. So now we can write this as 1/2 fraction. Notice one trick that 57, the digits add up to 12. 5 plus 7 is 12. So that means that I know that 3 divides 57 since 3 divides 12. So here 3 goes into 57 19 times, and then 2 goes into itself once and into 4 2 times. So we will end up with 19 times 1 over 2 times 1, and at the end of the day we have a result of 19 halves. I forgot my equals sign. Let's be consistent here. Okay, next up, 3/14 minus 1/10. So here, remember that 14 we could write as 2 times 7, and 10 we can write as 2 times 5. So using that one method we learned earlier, we know that the LCD will be 2 times 7 times 5, which is equal to 70. So let's go ahead and do this. We'll write below here 3/14. I'm going to leave space so we can show how we got our common denominator. In order to get 70 here, we are going to have to multiply 14 by 5. So we pay for that by putting 5 in the numerator. And the 10, of course, we'll have to multiply by 7. So we balance that out by putting 7 in the numerator. And then we will have 15/70 minus 7/70, which gives us a result of 15 minus 7. Remember, we can do 1/2 fraction now, all over 70. So when we complete this step, we will have 8/70. So what do you think? Are we all done? Ah, you caught it. Good. We've got an even over an even, so I know for sure that I'll be able to divide out a 2. So let's just write it as 2 times 4 divided by 2 times 35. So notice that the 2's will divide out, and at the end of the day we will get a result of 4/35. So how'd you do on that one? All warmed up now? Awesome. Okay, so we start the lesson by talking about the vocabulary of algebraic expressions. So here we are. Terms. The terms of an algebraic expression are those parts that are separated, by addition or subtraction, A term is a number, a variable, or a number multiplied by one or more variables. Coefficient, the numerical part of a term, is called its coefficient. So what would the coefficient of a term which only has variables be? Good. It would be 1 or -1. Very good. All right. Next up, we have constant term, a term that consists of just a number, no variables at all, is called a constant term. Like terms, terms that have the, oh, sorry, I have an extra word here. Terms that have exactly the same variable. Factors are called like terms. What do you think about constant terms? Are constant terms like terms? Yes, they are. Constant terms have no variable factors, so therefore they would have the same variable factors since they don't have any, so they are considered to be like terms. That's why we can just either add or subtract them. So here we go. Let's look at this example. Consider the following algebraic expression. So we have -12 times x plus 9 plus 7 times x minus 8. How many terms are in the algebraic expression? Good. Just don't combine like terms in your head. Look at the expression exactly as it is, and we've got 1, 2, 3, and 4. So we have 4 terms in total. So what is the coefficient of the first term, -12x? Good, it's -12. Which terms are the constant terms? Got 9 and, don't forget the minus, it got -8. What are the like terms in the algebraic expression? Well, we've got -12 times x and 7 times x, since they both have x to the 1's in them, and 9 and -8. Okay. Equivalent algebraic expressions. Two algebraic expressions that have the same value for all replacements are called equivalent algebraic expressions. So let's take a look at example 2. Let's evaluate these two algebraic expressions at x equal to 2. So remember, wherever we see an x, in each of these, we will plug in 2. So we have negative 12 times 2 plus 9 plus 7 times 2 minus 8. That will be, so this is where we replace the 2 in the first one, negative 24 plus 9 plus 14 minus 8, which is, let's see, negative 15 plus 6, and we will get an end result of negative 9. So when x takes on a value of 2, we get a result of negative 9 when we evaluate this algebraic expression. Now this guy will have negative 5 times 2 plus 1. So this is where I plugged in the x equal to 2. So this is negative 10 plus 1, and hey, we get negative 9. So what have we discovered? So these two algebraic expressions are equivalent. And what you may have noticed, right, if we kind of sneak up here and take a look at this one, if we combine like terms, so if we said negative 12x plus negative 8x, and then we have the 9. Oh, whoops. Remember, you're supposed to stop me when I'm making up my own math. We would have plus 7x, and then the 9 plus the negative 8 would just be plus 1. And then this would give us negative 5x plus 1 when we combine these like terms. And look down here. Do you see that was the second algebraic expression? So you can simplify the first one to get the second one. Okay, the commutative properties. A and B are real numbers, variables, or algebraic expressions. So the commutative property of addition says if you have A plus B, you can move the positions of A and B, and you would get B plus A. So changing order when adding does not affect the sum. Similarly, the commutative property of multiplication, if you have A times B, that is equal to B times A. So changing order when multiplying does not affect the product. Okay, so go ahead and pause the movie and do example 3 where you want to use the commutative property to write an algebraic expression that is equivalent to each of the following. So let's see how you did. So here for the first one, I'll go ahead and use the commutative property of addition. So this would be equivalent to 4 plus 2 times x. And this here, we would get 13 times x. And remember, when you have a number right next to a variable without any symbol between them, that implies multiplication. All right. Associative properties. So A, B, and C are real numbers, variables, or algebraic expressions again. So what the associative property addition states is that if you have A plus B grouped, and you add some C, that's going to be equivalent to A plus B plus C being grouped. So changing grouping when adding does not affect the sum. And this is something that we do quite often when we are doing mental arithmetic, and you just don't realize you're using the associative property. So the associative property of multiplication, similar deal. If you have A times B grouped times C, then that's equivalent to A times B times C being grouped. So changing grouping when multiplying does not affect the product. So this is why these properties are useful. Let's take a look at these examples. Here, do you see that? First, we are going to use this one's going to use both of them. The first example will use both. First, we're going to commute the 7 and the x. So we will get 4x plus x plus 7. So we use the commutative property. For that first one. And then, in this next line, if we change the grouping symbol to surround the 4x plus the, remember that would be 1x, and then increase by 7, this one is the associative property. Now, completing this one, if I have 4 x's plus 1x, I'm going to get 5 x's overall, and then I still have the plus 7 hanging around. All right, so let's check out this guy. This one we can use the associative property directly. If we put the parentheses around the 25 times the 4, look how much easier that's going to make this problem. So now we can multiply 4 25s makes 100. So we get 100 x's. So this was the associative property. How you doing? Hanging in there? We're about halfway done with this lesson. Okay. The distributive property. Again, A, B, and C are real numbers, variables, or algebraic expressions. So if we have A times some sum B plus C, that's equivalent to A times B plus A times C. Now, it's important that you know this both ways. You know, at the beginning, you will learn about going this direction, left to right. But when we learn about factoring, you're going to have something like this. You'll have A times B plus A times C. Whoops. A times C. And what you'll need to recognize is that that's equivalent to A times this sum B plus C. Very important that you learn it going both directions. Left to right is the same as right to left. So this says that multiplication distributes over addition. So here we go. If we use our distributive law, we'll be looking at this as 3 times x plus 3 times 5. So in this case, if you just take a look at your at what we have going on here, your A in this case is 3. Okay. Your B is the x, and your C is the 5. So then this gives us a result of 3x's plus 15. Now, number 2, this is the opposite of the sum 4 plus x. So that negative kind of distributes through. You can think of it as a -1 multiplying through that sum. So we will have, in this case, the a is the negative, the b is the 4, and the c is the x. So this will be -4 and then plus -x. And this is how they match up to the rule. So this, of course, would just be -4 minus x. Okay. Now we'll move on to other forms of the distributive property. So here we go. This meaning here, when we have a times the quantity b minus c is equal to a times b minus a times c. Multiplication, I'd rather use the black. Multiplication distributes over subtraction. So some examples, we could have 5 times x minus 2. That would equal to 5 times x minus 5 times 2, which is 5x minus 10. So this portion right here is the illustration of the property. And then the bottom is the end result. Okay, next up. This next box means that multiplication distributes over 3 or more terms in parentheses. So if I add 2 times, x plus y plus 7, that would be 2 times x plus 2 times y plus 2 times 7, which would give us an end result of 2x plus 2y plus 14. So again, this is the end result. And then these first 2 lines are the illustration of the property. Now, this is something that we also use as we go on in math. Multiplication on the right distributes over addition or subtraction. So here, this result would be, let's write down this stuff in words. Multiplication on the right distributes over addition or subtraction. So an example, if we had, we could do x minus 5 times 4 would equal to x times 4 minus 5 times 4. So this here is the illustration of the property, and this would give us a result of 4x, if I use the commutative property, minus 20. Okay, so let's move along to combining like terms. We will be combining like terms many times over the course of the semester. So the distributive property lets us add and subtract like terms. So let's just take a look. This isn't normally how we work these problems out, but if you just look at an example, suppose we had 5x plus 8x. Now couldn't we write that as x times 5 plus x times 8 using the commutative property for each term? And then if you look at that, think about it. This x shows up twice, and then you've got the 5 and the 8 here. So if you use that distributive property kind of backwards, if you will, you end up with x times 5 plus 8, which is x times 13. And again, this comes from using the distributive law backwards from what you were shown. And then we traditionally will write this as 13x. Okay? So what you want to check is to see if you have the same variable raised to the same power. So each of these are just x to the 1 power. If you don't see a number, it implies it's raised to the 1 power. So example 6, we're combining like terms. Okay. So here we go. The first part will be, we will have 12 x's, and then we will have minus an x, and then plus a 21. So 12x minus 1x gives us 11 x's, and the plus 21 just goes along for the ride. Okay. You go ahead and pause the movie and try the next example. All right, let's see how we did. So this one will be 9x plus, I can just remove the parentheses from the x plus 5 because I'm just really multiplying them by a 1. So it's not meaningful other than to group them. Now, this is going to be minus 2 times negative x plus 2 times 11 plus 2 times 3y. So I kept the minus on the outside and I distributed the 2 throughout. Okay. So here, the 9x plus the 1x yields a result of 10x's. We'll have plus 5. We'll have minus a negative 2x, minus 22, and then minus 6y, which will be 10x's plus 5 plus 2x's minus 22 minus 6y. Now notice that the 10x and the 2x are like terms, and the 5 and the negative 22 are like terms. So we'll get 12x's plus, whoops, that'll be a minus 17, and then we'll have a minus 6y. So here's some steps that you can follow for simplifying algebraic expressions. Use the distributive property to remove parentheses. Rearrange terms and group like terms using the commutative and associative properties. And as you hone your skills, you're going to be doing this step mentally. All right? And then thirdly, we'll be combining. So you combine like terms by combining the coefficients of the terms and keeping the same variable, factor, or factors. I'll just put a parenthesis S here. Okay, so let's take a look at an application. So the percentage of U.S. women, denoted by W, who use the internet in years after 2000 can be modeled by the formula W equals 2 times the sum of 2n plus 25 plus 5/10 times the sum of, whoops, looks like somebody's calling me. Sorry about that, guys. We'll just ignore that call. 5/10 times the sum of n plus 2. So let's simplify this formula. Right? So when we simplify the formula, we would have W equals, so I'm going to go ahead and rewrite it before I simplify. So here we go. We can distribute the 2 throughout that 2n plus 25. So we will get 2 times 2n plus 2 times 25. And then we can also distribute that 5/10 throughout the n plus 2. So we'll have 5/10 times n plus 5/10 times 2. So then W will be 4n plus 50 plus 5/10 times n, and then plus, when I multiply the 0.5 and the 2, I will get 1. Next step, we will have W equals, we will have 4.5 of the n's, and then we'll have plus 51. So we now have the simplified version of this formula. All right, so now we are instructed to use the simplified form of this mathematical model to find the percentage of U.S. women who used the internet in 2005. So what is n going to be? So n is the number of years. Remember, we'll go back up here. In years after 2000. So do you see that 2005 is 5 years after 2000. So n must be 5. All right, so let's come back over here. W equals 4.5 times n plus 51. So we are going to evaluate this equation at n equals 5. So we'll get W equals 4.5 times 5 plus 51. And this is where we're getting the 5, plugging that in for n. And we will get W equals, so we'll have, let's see, 5 times 5 is 25. I believe we'll have 22.5 plus 51. So W will be 73.5. Now, we've got an application, so let's answer the question in words. All right? 73.5% of U.S. women used the internet in 2005. And put your happy box. You got everything all figured out. Okay, that wraps it up for this lesson, and have a wonderful day.